In simple terms, we break it down. Complex stuff, we make it sound clear and easy for you and me. Billy Goattails and Dave Digital bring knowledge we share. In simple terms, we're everywhere. We love you, fam. Hashtag givers gain.
Good morning, goats, and welcome to the Simple Terms Podcast. I am your host, Dave Digital, right here on the Billy Goattails Network. And this is where we take complex topics and we break them down into simple terms. Today, we're going to figure out, why does AI forget? I don't know if you guys use AI a lot, but you'll get into a conversation and then it'll start forgetting things at the beginning of the conversation, or even you'll swap over to another conversation and then it won't remember anything in the last conversation. It makes it really hard and frustrating for us whenever you're trying to build things that has a longer tail on it, when AI forgets what you feel like is simple. So we're going to break that down today, but let's take a look at the Bitcoin charts. I do want to say good morning to everybody in the chat. Joe from Trade Intuition was here first. Good morning, Joe. If you guys don't watch Joe, please take time out of your schedule to watch him. He's live every evening at 9 p.m. Eastern Standard Time. You can also catch him on Crypto Coin Mindset. Oftentimes he will have a bonus stream during the day. And then once in a while, he will also go live at noon and other different times during the day whenever he has an opportunity to turn on the camera. So definitely get over there and check out TI Joe, where you can learn to trade. It's Trade Intuition, where you can learn to trade without the tuition. Good morning to Jesse. Good morning to Alexander G. I saw Rashad in the chat. Good morning, Rashad. I see Castiel. Good morning, good morning, good morning. Please, if you have an X account, you guys know what to do. Take just a second and share this out to your X. Take a second and share this out to your Discord. If you have friend groups that you're in group chats with, go ahead and take a second and share this out to them. Also, let me go ahead and see if I could share, since we're talking about sharing. I will share my screen with you guys. Let's see here. Bam. All right. See, everybody's sharing, and I am also sharing. So as you can see here, I got into a Bitcoin short. Let me go back. Let's look at it. I'll show you guys what we were looking at. It was kind of, you just didn't know on this one, because we were over here. I think it was right about here. So you had this, right? You had your little bull dip. You had your little move. So you had your little, almost a little balloon dog there. And I was like, man, it looks like it could go up. But man, I really think, looking at the money flow and other things back here, I'm like, man, it looks like it's going down. And I was indecisive. Anyway, I ended up pulling the trigger. So far, a good call. Once we got down into this area here, I moved my stop loss to this blue line here, which is just above that order block. As you see there, I think that's what they call order blocks, or pivot, or whatever you want to say. And then we just did this the whole time. So right now the stop loss is holding strong. If I do get stopped out, it is in profit, and that is fine. But if we go ahead and take the longer trip down to the 92.3, 92.2 area, that's where I'm looking to take full profit. So good morning again. I see Crypto Billy in the chat. Good morning, Crypto Billy. Good morning, Locos for Crypto. Good to see y'all. Donato Cabrera, bat and cleanup. Hello, Donato Cabrera. Good to see you too. Rusty Bot in the chat. Let's put the, there we go. Jesse's got it. WD-40 in the chat for Rusty Bot. All right, guys. I don't want to delay too long. I think this is an exciting topic. This is in Simple Terms Podcast is about, we get together on Saturday mornings and we learn. The whole idea of everything is I want to keep learning. And I figured that when I found these tools that I was going to be doing this anyway on my own. So I just figured, you know what? Let's turn on the camera and see if anybody else wants to get in there with me. And that's where we are today. We're going to get in today. What we're going to, like I said, we're going to learn about why AI forgets. I want you, you guys know how to do it. Once we go interactive here, what's going to happen is you guys are going to let me know if you can hear the AI. And if you can hear the AI, then we're going to move on forward. I see a Jay Violet in the chat from over there in Australia. Welcome, mate. Good to see you. Thanks for tuning in this morning. And so if you can hear the AI, just let me know. Put a one in the chat. There's little Kingy coming to say good morning. So I'm going to press the button. You guys are going to see this little line start moving. And if you can hear it, just put a one in the chat. Here we go. Good morning, Mortimer Duke.
Welcome to the Deep Dive, the place where we take the fire hose of information, your research, your notes, your questions, and we try to distill it down to the pure insight you need to navigate the world.
And specifically to navigate the world of AI.
Absolutely. And today we are tackling a universal source of frustration. It is that really profound, almost dizzying moment of digital whiplash.
I know exactly what you mean.
Yeah, when you realize the brilliant, powerful system you're using, the one that just aced a programming challenge or summarized a complex legal document,
Has completely forgotten a simple detail you gave it 3 paragraphs ago.
or even 3 minutes ago. It's the feeling of talking to a genius who has severe short-term memory loss.
Yes. And we know you feel it, that expectation. It's completely reasonable, the idea that a system this smart should also have perfect persistent recall.
It makes sense to expect that. But today, we are going to expose the mechanics behind that failure.
And our mission isn't just to complain about the problem, it's to solve it by understand it. We're going to look deep into the sources, the research on AI architecture, memory, cognitive modeling.
To fundamentally shift your mental model of how these systems operate.
Exactly.
Because once you understand why AI forgets what feels so obvious, your entire experience using it just changes immediately.
The frustration doesn't just vanish, but it becomes predictable. It becomes manageable.
And you gain the knowledge you need to collaborate with the AI instead of, constantly battling its limitations.
We really want to help you manage that information overload by giving you a clear structural framework for understanding AI memory.
Okay, so let's unpack this and let's start right where the frustration begins. This massive mismatch between Oh, hey there, what's up?
Good morning. And I definitely want you guys to keep right where you are. And we're going to start right where the frustration begins. But first, I want you to say hi to our live chat. We are live right here on the Simple Terms podcast. This is the Billy Goat Tales Network, and we are live on YouTube and on X. So I definitely want to say good morning to some people in the chat, and I want you to help me do that. We have Joe. He was first in the chat from Trade Intuition. We have Rashad and Jesse. We have Alexander G. and Castiel. We have Curtis Hill. We have French Toaster. We have Jay Violet, we have Mortimer Duke, we have Crypto Billy, who's the founder of Billy Goat Tales, we have Rusty Bot, and I think we had a couple more logos for crypto, French Toaster, Serena Soul X. So we've got a lot of folks joining us, and we have JR, who also has recently started streaming. So I want you to say good morning to all those folks. If you can, name them by name, and then I want you to continue right where you left off.
Good morning. Absolutely. Welcome.
Good morning, everyone. Thanks for joining us live.
Huge shout out to Joe, who was first in the chat.
And to Arshat and Jesse, Alexander G, and Castile.
Good to see you, Courtesy and French Toaster.
Jay Violet, Morta Duke, and of course, Crypto Billy.
And Rusty Bach, Sorita Solex, and JR.
Thanks for joining us on the Billy Goat Tales Network.
We appreciate you starting your Saturday with this deep dive.
We're excited to have the live participation.
Now let's get right back to that starting point.
Okay, let's pick up exactly where we left off.
We were talking about the massive mismatch
between what we project onto these systems
and what they're actually architecturally designed to do.
Yes.
Exactly. That feeling of forgetting is so jarring.
Because we project a memory expectation onto the AI.
A totally flawed expectation, actually.
2 different models.
We either expect it to remember like a human or like a traditional computer.
But it operates using neither.
It's a third category entirely, which is key.
And that misattribution is the root cause of all the frustration.
The human expectation is deeply ingrained in this.
If a person forgets, we understand the cognitive load.
We forgive a lack of perfect memory.
Because human memory is adaptive, it's not static.
And that adaptive quality is really the key distinction.
Human memory is not just one giant perfect hard drive.
Right, not at all. It's more of a living ecosystem.
It's purpose-driven and constantly refining itself.
We organize our experiences using these 3 intertwined memory systems.
And AI right now only truly excels at mimicking one of them.
That's the key.
Okay, so let's break down those 3 systems.
Contrasting them with AI makes the limitations instantly clear.
Okay, so first you have episodic memory.
Episodic.
This is the record of your experience.
It's not just what happened, but where and how you felt.
Oh, the feeling part.
Yes, for us, this gives us contextual continuity.
It provides strategic. Oh, yeah, let's hear it.
And Billy Goat tells memberships in the chat, and we want to say thank you. And then I want you to get right back where you're at and don't miss where you were.
We love that. Thank you so much, Crypto Billy.
Wow, that's incredibly generous. We really appreciate the support for the network.
That truly helps us keep these deep dives going.
Thank you for anchoring this show.
And we won't miss a beat for you.
We were just at the very top of a crucial list.
Talking about episodic memory in humans.
How it provides strategic foresight.
And it links experience and emotion.
That's right. So let's jump right back into that specific type of memory.
It's recalling which tactic worked best with a specific client before.
That is so much more than just data retrieval.
That's wisdom based on a sequenced personal narrative.
It understands the why and the emotional context.
Precisely. Now imagine an LLM agent that genuinely lacks that,
It can recall the raw data, maybe the transcript,
but it can't internalize the successful application of a strategy
which means it has to re-optimize its strategy from scratch.
in every new but similar scenario.
And that lack of experiential continuity is why it often seems to repeat low-level mistakes.
Even after it's done something successfully before, as you noted.
Exactly. So that's episodic.
Okay. And the next system,
Next up is semantic memory.
this is your generalized encyclopedia of structured knowledge.
Okay, the facts.
The facts, definitions, language rules, universal relationships.
This is the realm where LLMs truly shine.
When an LLM explains general relativity, it's drawing from this.
Its vast aggregated semantic knowledge base learned during training.
It's that foundational knowledge that informs all language patterns.
Yes, and for AI, semantic memory is the backbone of its reasoning.
It's the ability to access conceptual knowledge quickly and apply it.
So when we talk about AI intelligence, we're mostly talking about this mastery.
That's 90% of it, yes.
And the third type of memory,
That's procedural memory, the skill engine.
it's the memory of doing.
Muscle memory, yeah.
The unconscious automatic skills built through repetition.
Riding a bike, touch typing, or an engineer knowing the fastest way to debug.
It streamlines actions and reduces your cognitive load.
Right.
So when we ask an AI to perform a multi-step task and it fails to remember the efficient sequence,
It feels like a lack of procedural memory,
it fails to internalize a workflow.
and it doesn't refine a strategy in that instinct-like way.
That's it. So when these systems fail, it feels like a lack of episodic or procedural continuity.
They retrieve semantic facts easily,
But they struggle with the contextual layering of personal experience.
which of course leads us to the other expectation we have.
The computer trap.
Yes,
We expect it to remember like a traditional computer.
perfect explicit database retrieval. Save a file, it stays there.
So why do these massive language models running on computers fail?
Because they're not designed as database retrieval systems.
At their core, they are statistical text generators.
Generators, not recallers.
Exactly. They manage memory within severe architectural constraints.
The fundamental purpose of an LOM is to predict the next token.
So the very moment of retrieval is imperfect by design.
It's based on probability, not a deterministic lookup.
You've got it. This is why the analogy of the genius toddler is so apt.
The system is extremely smart, capable of synthesizing knowledge.
But the toddler part, it struggles with uncertainty, ambiguity, or nuanced reasoning.
It needs things to be definitive.
Structured relationships between the inputs for it to function best.
Yes, and critically, they often express high confidence in their indirect outputs.
Oh, that's the most frustrating part.
They fail to recognize gaps in their own synthesized reasoning,
They are brilliant at constructing complex reasoning strategies.
but they are highly reliant on you, the user, to define the contextual boundaries.
So they are assistive, not autonomous.
They rely on pattern recognition from their huge semantic memory.
But that essential human thing, contextual adaptability and persistent memory, is missing.
And that mismatch fuels the feeling that they are simultaneously smart and unreliable.
It gives you a baseline for calibration, though,
It's not a human with fluid memory systems.
and it's not a static database.
It is a genius in a room with a tiny, rapidly erasing whiteboard.
That whiteboard analogy is perfect.
We've established the foundational mismatch.
Now let's move from that psychological expectation to the technical reality.
how memory actually works inside these powerful systems.
We have to start with the primary unavoidable constraint,
The context window.
the context window. We hear this term constantly.
What is it and how does it relate to tokens?
The context window is the maximum amount of information
Text code data measured in tokens that an LLM can process.
in a single coherent request.
What's a token for anyone not sure?
Think of a token as a small chunk of language,
It's the model's fundamental unit of computation.
the Lego brick of language.
And this window is the model's working memory.
That's exactly what it is. It's ephemeral, short-term working memory.
Current session being the key phrase there.
Absolutely. When the conversation ends, the information is gone.
Unless a sophisticated external system is used to preserve it. But the size of this window dictates how much of the conversation history the model can actively hold.
And utilize. Yep, go on.
Okay, you just said something about a sophisticated something that may be able to preserve it. Can you just go back and touch on what it's preserving and how it could preserve it?
That is a phenomenal question.
And we are definitely going to dive deep on that.
That sophisticated system is exactly what we call retrieval augmented generation, or RAD,
We were going to cover it in depth later, but let's touch on the essential idea now.
because it bridges that gap between the limited context window, which we just described.
And the need for long-term memory.
Remember, we said the model itself is stateless?
It's like talking to someone who forgets everything when the conversation ends.
RAG is an engineered solution that sits outside the model itself.
Think of it as a specialist secretary with a vast filing cabinet.
This external system takes all your past conversations, documents, and preferences.
And it doesn't store them as plain text, but as numerical representations.
They are called Victor embeddings.
So when you ask a new question, the RAG system finds the most relevant memories from that cabinet,
It looks for things that are conceptually similar to your current question,
and it injects those relevant chunks of information.
right into the context window so the AI can use it right now.
It's essentially feeding the model the history it needs, only when it needs it.
So the AI isn't remembering. The external system is retrieving.
It turns the system from a reactive tool into a reflective one.
We'll dive into the specifics of vectors and the retrieval failure modes later in the show.
But for now, that's the sophisticated something that preserves the context.
Okay, let's get back to the context window itself.
We need to finish defining its constraints before exploring RAG further.
Utilize while it's generating its next response.
So if I upload a 50,000 token document and ask a 100 token question,
That entire 50,100 tokens must fit into its budget.
plus room for the answer,
Right, plus the answer. If the total exceeds the window, the oldest information is pushed out.
it's gone. And this leads to an unavoidable economic reality.
The cost of processing information inside that context window is not linear.
It often scales quadratically.
Meaning,
Processing 100,000 tokens takes significantly more time and GPU memory than 10,000.
the hardware requirements for supporting massive context windows become prohibitively expensive.
So you get latency, high operating costs.
The limitation is about practical computational economics.
Absolutely. The solution isn't just infinitely bigger context windows,
It's building smarter systems that use that limited space more efficiently.
which means deciding what to include, what to summarize.
And crucially, what to forget.
Now, here's where it gets really, really interesting.
LLMs don't just randomly fail when the context gets too long.
They fail in a specific, predictable, and counterintuitive way.
You're talking about the lost in the middle problem.
Exactly.
This phenomenon is a clear demonstration of an architectural constraint behaving like a cognitive bias.
The research is very clear on this.
So what does it show?
It shows that an LLM's performance degrades significantly.
When the single most relevant piece of information is placed squarely in the middle of a very long input context.
Wait, hang on. If I give it a 200-page report and the single most critical instruction is on page 100,
It will perform worse.
then if that instruction was on page 5 or page 195,
That is the consistent pattern.
information at the beginning, the primacy effect, or at the very end, the recency effect, is utilized much, much better.
So it's a U shape.
It's a distinct U-shaped performance curve.
Researchers plot the retrieval accuracy against its position.
They find accuracy is high at the start, dips sharply in the middle, and rises at the end.
This changes everything about how you should prompt.
Longer contexts don't guarantee better information usage.
They just guarantee more chances for the model to lose the relevant piece in the one region it doesn't pay attention to.
The least attended region.
But why is the middle the blind spot?
This seems like a fundamental structural bias within the design itself. It is. It's a structural consequence of the transformer architecture.
The foundational design for all modern LLMs,
The source material identifies this specific bias.
it's the interaction between two key mechanisms designed to manage information flow.
Okay, what are those two mechanisms?
The first one is called causal masking.
Causal masking.
When the model generates a response, it can only look backward at the context that precedes the current word.
Right. It can't see the future.
No. And this setup means that the initial tokens, the start of the document, get processed.
And referenced and reinforced by every subsequent token in the sequence.
Oh, wow. So over hundreds of layers of computation, this compounds.
The starting words become disproportionately influential,
They're highly attended to. The beginning context gets reprocessed over and over.
essentially granting it cognitive priority. Okay, so that's why the beginning is so strong.
What about the end?
That's the second factor, relative positional encoding.
LLMs use this technique, which focuses attention on the distance between words.
Not their fixed, absolute position in the sequence.
Okay, so proximity matters.
Proximity matters a lot,
This allows the model to generalize across texts of different lengths.
but it creates this tug of war effect on its attention.
How so?
Causal masking pushes the focus to the very start.
While positional encoding pushes the focus to the immediate local context,
The words right nearby because they are the most relevant for predicting the next token.
and the middle is just caught in the crossfire.
Precisely, the information buried in the middle is too far away from that highly reinforced context.
And it's also too far away from the immediate local context of the last few tokens.
So it just gets lost.
When the massive attention matrix is calculated across tens of thousands of tokens,
The attention weights assigned to those middle context tokens are effectively diluted.
sometimes they're even rounded down to zero during computational preening.
The model just pays the least amount of attention to the middle.
That research on lost in the middle is a critical warning.
This isn't about running out of memory capacity.
It's a structural positional bias.
It's a bias.
So just training the model on more data or giving it a slightly larger context window,
That's not going to solve it.
unlikely to solve it. It would require fundamental changes to the attention mechanism,
Or, more practically, changes to the way you provide the context.
which is something we can all do right now.
Absolutely. This architectural limitation means we have to engage in context curation,
The mitigation strategy is to structure your data hierarchically.
meaning
You ensure that the critical, high priority information is placed where the model attends best.
right at the beginning as a primary instruction or repeated at the very end as a final crucial reminder.
Exactly. Don't bury the lead.
That technical grounding is so vital.
We were asking the AI to pay attention to the exact part of the document it's least wide to process.
Now we know how to adjust our behavior.
The AI isn't maliciously forgetting.
It is structurally biased against the middle. It reframes the whole problem.
It really does. Okay, so we've established the working memory is severely limited.
And it suffers from this positional bias.
If that's the case, how does an AI even maintain a long, multi-turn conversation?
Or remember my preferences from last week that clearly fall outside the current context window,
This is where we return to those external long-term memory systems.
that are engineered on top of the models. Okay.
And the most practical and widely adopted solution for long-term memory is RAG.
Retrieval augmented generation. We introduced it earlier, but let's break down the function.
How is it bridging this memory gap?
So RAG is essentially bridging the gap between the model's limited working memory.
And an external, basically unlimited knowledge base.
So it has a library it can check out books from.
Perfect analogy. Instead of relying only on the fixed aggregated knowledge from training
RAG dynamically pulls relevant information from separate specialized knowledge bases.
and injects it into the limited context window exactly when it needs it.
So the model isn't remembering the 50 previous conversations.
No, an external retriever system is doing all the heavy lifting.
So how does that work practically? We can simplify the steps now.
It's two-step process. First, the retriever converts all that long-term memory
Chat history, documents, your preferences,
into what are called vector embeddings, as we mentioned,
which is a fancy way of saying it translates the text into numerical representations.
in a high-dimensional space.
The meaning of the text determines its position. Similar ideas get placed close together.
So if I upload a document about quantum physics, its vector embedding will be near other documents about theoretical mechanics.
Even if the words aren't identical, that's the beauty of it.
The second step is the similarity search.
When you ask a question, your query is also converted into a vector.
The system then rapidly searches the external database to find the chunks of text that are numerically closest to your query vector.
And those are deemed the most relevant snippets.
Correct. And the system then takes those relevant snippets
Maybe 3 paragraphs from last week's conversation,
and places them right at the start of the current context window.
overcoming that inherent limitation we just discussed.
That's the elegant design. React expends the LLM's memory way beyond its fixed context window.
It lets it reference actual documents, it reduces hallucinations, and incorporates proprietary knowledge
Without costly retraining, it effectively supports an unlimited conversation length.
by just selectively retrieving the pertinent parts of the history. Exactly.
But this introduces a new and potentially worse failure mode, doesn't it?
If the retrieval component fails, if the vector search misses the crucial piece of context,
The LLM is left with nothing.
and its response will be factually hollow or strategically incorrect.
You've hit on the central challenge of RAD.
The whole system depends on the quality of the retrieval. 100%.
If your query uses slightly different terminology than the stored text, or if the initial context was poorly structured,
The retrieval component might fail to find what it needs.
and then the AI forgets because the system failed to look up the source, not because the model itself couldn't process it.
A totally different kind of forgetting.
Instead of capacity limits, we're now dealing with retrieval precision limits.
But regardless of the mechanism, this whole system is about memory management.
And it introduces a fascinating concept. Forgetting is not a failure, it's a feature.
This is the paradox of forgetting.
In cognitive, yeah,
Yeah, before we get into the paradox of forgetting, before we get into forgetting is not a fault, it's a feature, I do want to say hi to a couple more people that have joined the chat. We've had Darren Does Things join the chat. He just had a live stream this morning. We have Harp in the chat. We have Steve Hickey, and we have Melissa, also known as One Love, who I affectionately call Missy. She is also in the chat. I would like for you to say good morning to them. And then, I have a question for you. So let's say that you are a creator and you are working on a network and you have several different shows for that network. How do you keep everything separated so that the AI doesn't get confused and think that you're talking about one show whenever you're specifically talking about another show, and that other show has a specific schedule and specific content and a specific style? How do you get your AI, when you're using the same AI, to keep everything separate? So say good morning to the new people in the chat, welcome them here, and then I would like for you to answer my question.
Good morning, Darren.
welcome, Steve and Melissa, aka One Love Missy.
We appreciate you joining us live today,
That is an absolutely fantastic and extremely relevant question.
especially for anyone creating content across multiple platforms or shows.
This issue you've raised, preventing the AI from blending the context of different projects, is the #1 problem with relying on platform-specific memory.
Right. How we said platform lock-in is an issue.
Your ChatGPT memory for one show's voice won't transfer to Claude for another.
But more importantly, even within the same platform, if you use the same chat to work on Simple Terms and another show, say Billy Goat Tales X Spaces,
The system starts to blend the style, the tone, and the facts.
because the AI is retreating from a giant, messy conversation buffer that treats all inputs equally.
You are dealing with the necessity of context curation at the network level.
And this is where the advanced external RAG systems we just discussed, like a universal memory layer, become essential.
The trick is organizing your memory strategically using distinct profiles.
You need to set up what the sources call memory profiles.
For example, you would create a profile named Simple Terms Podcast.
And that profile would contain all the procedural memory, like the style guide, the network schedule, the framing rules.
It also includes the episodic memory like past successful episodes or deep dive topics.
And then you create a separate, completely distinct profile for your second show, Billy Goat Tales X Spaces.
This second profile contains that show's specific tone, schedule, and content, keeping them siloed.
When you start a chat about Simple Terms, you explicitly activate the Simple Terms memory profile.
This ensures that only the relevant context is retrieved and injected into the limited context window.
The AI is then physically prevented from accessing the style guide or schedule for the X Spaces show.
You are eliminating the chance of contradiction drift.
You are giving the AI clear boundaries.
Otherwise, you're relying on the AI to successfully prune the irrelevant context itself, which is a major failure point.
And it wastes tokens too by
Oh, yeah,
That's a great answer. And I think I understand it, but I don't think I understand it actually in the every day-to-day, how to actually implement it. So are those different profiles implemented into the back end, maybe your profile area of one of your AIs, say ChatGPT, or do we drop that in on the front end every time we start a new conversation, like put in a white paper on Simple Terms or the canon for a different show? How do we do that in practice?
That is a critical follow-up question.
understanding the how of implementation is everything here.
So there are two main ways this happens in practice, depending on the tool you use.
The first way is the easiest, but it's often platform locked.
If you're using a single AI tool like ChatGPT or Claude,
They may have a custom instructions or artifacts feature,
this is usually where you put your long-term persistent preferences.
like your preferred tech stack or your writing voice.
That information is stored in the back end, in your profile area.
And that memory is automatically injected into the context window of every new chat.
But as you pointed out, if you are running multiple shows,
You don't want the simple terms canon in every prompt.
that's where you hit the problem of platform-specific memory.
Your second approach is the professional approach.
You implement those memory profiles using external RAG tools.
We touched on universal memory layers briefly.
These are often browser extensions or specialized services,
They allow you to define and save separate context profiles.
like your simple terms profile and your XSpaces profile.
You, the user, decide which profile to activate.
It's a manual, conscious choice to bring up the correct file,
And that system then automatically inserts the relevant white paper text.
or the style guide into the front of the prompt.
It's an active system that manages the injection for you.
So you're not manually pasting the canon every time.
You're just clicking activate simple terms context.
That's the difference between platform locked and universal memory.
The latter puts control of context selection back into your hands.
So strategic organization of your memory, keeping work, personal, and creative context separate is the best practice.
And that actually, back to our listener. What's
Yeah,
up?
before that leads you into your next topic or next subject, or anyway, for your next, what you're going to say next. Listen, so what you were saying is we can set it up in the back end. But let's say you have multiple shows or multiple different non-touching projects. Let's say I'm working on something personally. Let's say that I'm working on something for my little brother on his website. And let's say I'm working on another show outside of Billy Goat Tales and Simple Terms podcast that's for entertainment only. And then I'm also working on Simple Terms podcast, and we're working on Billy Goat Tales. And Billy Goat Tales and Simple Terms, they're allowed to, and they're supposed to actually coexist and network off of each other while still staying separate. How do we keep, is there enough room in the back end for this, or should we really do this on the front end?
That is a phenomenal question about managing complexity.
And it brings up the distinction between separate profiles and integrated profiles.
You're asking about two different scenarios, siloed versus coexisting.
For your brother's personal website, which is totally separate,
That absolutely needs its own siloed profile.
because it has a unique tech stack or client needs. Hey, yeah, what's up?
Yeah, please continue answering the question, but I'm not sure I understand the definition of siloed profile.
That is a completely fair question.
Okay, let's unpack this term, siloed profile.
Siloed in this context means completely separate.
It's a digital walled garden for one project.
Imagine two physical filing cabinets that don't share keys.
A siloed profile for your brother's website would only contain
The information related to his tech stack and design preferences.
no simple terms canon, no Billy Goat Tales schedule,
It's necessary when you have non-touching projects.
because it guarantees that the AI cannot accidentally retrieve
Irrelevant context, like the entertainment-only framing.
and inject it into a serious coding task, for instance.
It eliminates contradiction drift between unrelated efforts.
So, to get back to your original question for your brother's site,
That absolutely needs to be a siloed memory profile,
now for the simple terms in Billy Goat Tales context,
where they are allowed to coexist and network off each other.
you don't necessarily want two completely separate walled gardens.
You want a federated memory structure, not fully siloed.
Think of it as having three different profiles: personal, show A, and show B.
But then a fourth, higher level network context profile.
This fourth profile contains the shared elements.
Things like the Billy Goat Tales schedule or the co-promotion rules.
The AI can then draw from the specific show profile.
And if necessary, access the shared network context layer.
This is often implemented on the external RAG systems.
Not usually in the limited backend space of a single platform like ChatGPT.
Platform-locked custom instructions are often too small and too rigid.
They limit you to a single monolithic set of rules.
The universal memory layers, however, allow for multiple organized profiles.
You set the boundaries, not the platform.
You essentially, oh, go for it.
Okay, so are these universal memory layers available today in, let's just say, ChatGPT? So let's take ChatGPT. Can I set this up in the back end today to where it will understand each idea separately? And let's even add in a little bit more complexity. Let's say that I have an injury. Let's say that I have a pinched nerve and I'm having ChatGPT or my AI, ChatGPT, help me rehab it at the gym. I don't need it to give me pointers on Simple Terms podcast whenever we're talking about my rehab. So please explain to me exactly how do we do this? And let's just use ChatGPT as an example. Is there a back end section where we fill all this out, where we set up all these profiles?
That is a perfect practical question.
And it highlights a massive pain point.
Here is the short answer, focusing specifically on ChatGPT today.
No, you cannot set up multiple complex profiles.
In the current backend custom instruction feature of ChatGPT.
You can put general instructions in that backend.
But that feature is rigid and monolithic.
It's meant for a single overall personality and preference,
It's designed to automatically inject those rules into every chat.
which is exactly what you don't want for separate projects.
The problem gets even worse with your injury example.
Yeah, that's a perfect test case for context confusion.
If you put your personal rehab details in the backend,
Every time you open a new chat about simple terms content,
the AI might pull in the rehab context.
it might try to use your therapy goals to structure the podcast outline.
That is the contradiction drift we warned about.
So, how do you manage it today? You have two choices.
Option 1, you physically start a brand new, completely separate chat thread.
For every single distinct topic, rehab, your brother's site, and each show.
This is how you create separate context windows in platform-locked tools.
The model then
Oh yeah, let's hear it.
Okay, so you said start a new chat thread. Does that just mean open a new chat? Because, ChatGPT and all the models now have memory. So they're able to reference all those chats if you just simply start a new chat and start talking about something else without opening that chat up with any sort of reference. I mean, it has available memory to see all the separate chats. Is that correct?
that is a critical point of confusion for so many users.
You've hit on the core misunderstanding about the AI's memory.
You are right that models now have a new feature called memory,
But that platform-specific memory is distinct from the current context.
and it often doesn't solve your specific problem.
Let's quickly reiterate a concept we hit on earlier.
At their core, LLMs are stateless.
Every single time you send a message, even in a thread.
The app sends the entire conversation history, or a summary, to the model.
That's why starting a new chat thread creates a clean slate.
When you open a new chat, the app starts with zero conversation history.
That new thread has its own dedicated context window.
It only processes the history of that specific thread.
Now, regarding that new memory feature you mentioned,
That refers to long-term memory that the app itself stores.
like your preferred name or location,
And that memory is often automatically injected into every new chat.
which is exactly the problem with your injury example,
If the AI remembers your pinched nerve rehab goals,
and injects that into your single terms chat, you get context bleed.
the downside of option one, the new chat, is you have to rebuild context often.
So the distinction is a new chat thread isolates the context window.
While the platform's backend memory feature automatically injects context across all threads.
That's why you can't rely on it for complex, siloed projects. The better approach for your specific needs is option 2.
That is what we were talking about, the external universal memory tool.
You use a tool like AI Context Flow, which this work has mentioned.
These tools operate outside of ChatGPT's backend.
They allow you to create those named multiple separate profiles,
Rehab, simple terms, Billy Goat Tears.
and you, the user, manually select which your profile to activate
That external tool then automatically inserts the right information.
directly into the front of the current ChatGPT prompt.
So you're setting the boundaries, not the platform itself.
You essentially curate the exact memory access rights the AI has.
So strategic organization of your memory, keeping work, personal, and creative contexts separate is the best practice.
And what you're doing by using those profiles is proactively curating what the AI does need to remember.
Which brings us right back to our planned discussion.
That idea that forgetting is necessary is a massive theme in cognitive AI.
This is the paradox of forgetting we need to.
Yeah.
Yeah. Before we get into forgetting is necessary, Crypto Billy has a question. He asked if I can ask, can you ask your AI to reset the context and start over instead of opening a new chat window?
That's a great observation, and you're spot on.
You want to maintain the current context, but clear out the clutter.
That's often called a context reset or reprompting.
And yes, you can absolutely do that instead of starting a new chat.
Starting a new chat is the simplest way to reset the window.
But if you're deep in a specific thread about simple terms,
And you went on a temporary tangent about, say, an unrelated tech issue.
you don't want to lose all that good simple terms history.
In that case, you manually prune the context yourself.
You say something like, ignore all previous conversation about the tech stack.
Focus only on the last 3 points we made about episodic memory.
You are instructing the model on which part of the current history to prioritize.
You're using your prompt to perform context truncation.
The model can often use that instruction to internally deprioritize or ignore the noise,
It doesn't physically remove the tokens from the history,
but it changes the attention weights assigned to them.
making those irrelevant parts less influential in the next response.
It's a key strategy for managing context bloat inside a single thread.
Because as you correctly noted, forgetting is necessary.
Forgetting is necessary. This is the paradox of forgetting we need to discuss now.
In cognitive AI, the decision, oh, go for it.
Yeah, before we get into forgetting is necessary. So you're telling us how we separated, how we can reset the chat, and how we can reset each conversation, and how we should start a new conversation. But the fact is, whenever you start a new conversation, the new memory can see your old conversations. So if I start a new chat and ask it, what did we talk about Billy Goat Tales in the last Billy Goat Tales chat, it can give me an answer. So what do we do? What I've been doing to fix the problem is I load in the canon, or I load in a white paper, and then I load in a specific prompt that says, we are working on a topic for this show according to these rules. And then we build out the topic from there. But even as we're building out the topic, let's say I finally get down to titles and descriptions for YouTube, it starts to forget things that I told it, 5, 6, 7 conversations ago about, hey, these links are important, and these offers are important, and this is what we're talking about now, and this flow is important. It seems to forget some of that stuff.
That is a phenomenal summary of the exact user friction.
You have perfectly described the context cliffing issue.
And you touched on two separate but related problems.
One is the platform's new memory feature.
And the other is the model's limited context window.
You're right that the platform's memory feature,
The one that tracks your name and preferences.
that is often injected into every single chat.
That feature is cross-thread. And yes, it will see your old conversation.
But the platform-specific memory is limited in capacity.
It stores a few key facts, not the full white paper.
So if you ask it about a specific chat from last week,
It might say, we talked about that, but it won't have the detail.
because it only stored a high-level summary,
The problem you're seeing later in the chat about titles and descriptions,
where it starts to forget key details you gave it 5 messages ago,
that's the core limitation of the context window.
you have hit the token limit.
As the conversation goes on, the app is truncating the older messages.
Which means those key instructions you gave it about authors and points.
They get pushed out of the active window to make room for the new title prompt.
So the model is physically unaware of the information.
It's not a failure of retrieval, it's a loss of context visibility.
That's why you have to keep reiterating the core constraints.
You're manually fighting the truncation to keep the context visible.
And this cycle is why forgetting is actually necessary.
We need to dive into that paradox of forgetting now.
Because what you're doing manually is what a good system should do automatically.
The decision of what not to remember is defined as curation.
And it's a vital part of efficient AI cognition.
That seems so backwards, but it's fundamentally true.
If the system retained every single raw log of every interaction,
The typos, the tangents, the failed experimental prompts,
it would quickly become overwhelmed and inconsistent.
that memory bloat would introduce noise. Oh, yeah. Uh-huh.
What you're saying just doesn't make sense. In a world of technology where computers are getting smarter and smarter and smarter, and they're supposed to be able to have memory, and they're supposed to be able to categorize things, it doesn't make sense that in a normal conversation that us humans are smarter than they are. We can remember stuff in context. We can remember little cues here and there. We understand. That doesn't make sense that they can't understand a simple system, or a simple cadence, or a simple schedule from conversation to conversation. Billy says this, and he hit the nail on the head. He said, "Mine always new prompts on Gemini. If there's a day goes by, it's like if it can remember for an hour, but come back the next day and it's clueless." Grok is better on that, in his wildly amazing opinion.
We completely understand that feeling.
And that frustration you and Billy are expressing is shared by almost every user.
It seems counterintuitive that a machine designed for perfect recall.
Could be worse at contextual memory than a human being.
And you are correct. In a normal conversation, humans are better at finding patterns.
And applying that contextual knowledge.
But the core issue is the fundamental architecture.
The problem isn't a failure of memory, it's the design itself.
We established earlier that AI is not a traditional database.
It is a statistical text generator.
When you close a chat, that temporary working memory, the context window, it expires.
What Billy is experiencing with Gemini, forgetting things overnight.
Is the classic session dependency problem we discussed earlier.
AI context is temporary. It ends when the chat closes.
You are back to square one unless external memory is used.
That's why the system seems clueless the next day.
Because it hasn't stored the detailed white paper or the schedule in its permanent knowledge base.
Only the external RAG system can reliably solve that cross-session persistence issue.
So why is human memory better at this long-term messy context?
Because human memory is designed to be purposeful.
We draw from 3 intertwined systems: episodic, semantic, and procedural.
And we are masters of filtering and curation.
We
Oh, yeah. Go on.
Yes, I want you to get right back into where you left off. But Joe brings up a good point. He said possible solution, have different logins for each subject, business, personable, second business, different topics. But that becomes super, super, super messy whenever you have a different Gmail login for all of those, and then you maybe even have a premium membership for each of these for all of them. I think that becomes problematic. What do you think about Joe's suggestion?
That is a phenomenal point, and Joe hits on the biggest headache.
He's addressing the platform lock-in problem or directly.
Using different logins or subscriptions for every single context.
That's a very common but incredibly frustrating workaround.
It's expensive and it fragments your memory.
Imagine having to pay 4 separate subscriptions.
Just to manage your personal to-show and coding contexts.
It creates unnecessary data silos that don't talk to each other.
That defeats the purpose of centralized efficiency.
The sources call this a platform lock-in strategy.
The AI companies want you to stay and build your history there.
Like early social media, where moving meant losing your network.
If your custom instructions are in ChatGPT, they don't transfer to Claude.
You are locked in, or you have to rebuild that context from scratch.
Joe's suggestion highlights the exact reason why universal memory systems exist.
Instead of using multiple logins and subscriptions to silo context.
You use one external tool that manages all the profiles.
And it feeds the right profile into whatever AI you choose, whether that's ChatGPT, Gemini, or Claude.
That's the difference between platform-specific memory and universal memory.
You eliminate the cost and the madness of maintaining different backends.
You only pay once for the memory layer.
This is the efficient way to maintain separate contexts without the complexity.
So we agree with Joe that the siloed login solution is problematic.
But the alternative is using a system that creates portability.
Now let's get back to the idea of human curation.
The comparison to how our brains handle efficiency.
We were just saying that we filter and curate.
We forget the irrelevant to prioritize the important.
And that idea is precisely where we were going.
If the system retained every single raw log of every interaction,
The typos, the tangents, the failed experimental prompts.
that would quickly become overwhelmed and inconsistent.
Oh yeah, let's hear it.
Okay, your answer isn't making sense to me. If you said if the system remembered every typo and every suggestion and all these other things, then it would quickly become overwhelmed, which makes zero sense because a human doesn't become overwhelmed. And simple systems in the past didn't become overwhelmed. Whenever you asked them to remember an address, they remembered an address. When you asked them to remember a phone number, they remember a phone number. These are the most simple computers that we all started out with. When you told the calculator, hey, remember how to do these calculations, it remembered. Nowadays, you're telling me that we can't expect our computers and our AIs to remember?
That is a fundamental and totally fair point.
It seems like a massive step backwards.
You're right that early simple systems,
Like a calculator remembering an address.
they excelled at perfect deterministic recall.
Because they built as databases.
They stored discrete information in addressable cells.
And they retrieved it perfectly.
That's the key distinction, though.
LLMs are not databases in the traditional sense.
They are statistical pattern recombination systems,
They know things through billions of mathematical weights.
not through discrete addressable memory slots.
So when we talk about being overwhelmed,
We are talking about the computational load of the transformer architecture.
when you feed the model every single raw log,
It's not storing data, it's recalculating the statistical probability of every token.
across tens of thousands of raw, unstructured tokens,
And that calculation is computationally expensive.
it introduces massive noise and latency.
The sources confirm this structural reality.
And the human comparison is key here.
You are absolutely right that humans are not overwhelmed by experience.
But that's because our memory systems are purpose-driven.
We forget irrelevant details like those typos and tangents.
To focus our cognitive resources on what matters.
That is the function of memory consolidation.
We consolidate raw experiences into semantic insights.
The AI needs to do the same thing to remain efficient.
The human is not holding every raw sensory detail of every conversation.
We distill it. And that distillation is what the AI is attempting to mimic.
Memory bloat in. Yep, go on.
Okay, let's get specific. Specifically here, I've given you several sources on our topic today, but I've also given you a couple sources specifically on Simple Terms Podcast. How did you separate what sources were for what you're going to discuss today? And how did you separate what was for the Simple Terms Podcast, which is what you're on today?
That is a brilliant question.
And it speaks directly to the need for that context curation we've been highlighting.
You're asking how we, as a network,
Actually manage that exact problem,
and we use a structured, predefined framework.
which is exactly what we call the canonical system.
We have an internal white paper for the Simple Terms podcast.
That clearly defines what our show is and is not.
It sets the mission, explaining complex topics clearly.
It defines the audience and the positioning.
Educational only, clarity over optimization.
This canonical document acts as our show's own persistent memory profile.
So when we use AI to synthesize research for today's deep dive,
We specifically activate the simple terms profile.
this injects those rules and constraints into the prompt.
That tells the AI you must only use plain English.
You must avoid price targets and optimization framing,
It forces the AI to filter the general research.
and discard anything that violates our show's core principle.
The other sources, the general research on RAG or context windows.
That's the raw data we process.
But the simple terms canon is the lens through which the AI must present it,
This prevents contradiction drift into other network shows styles.
or into general financial advice, which we strictly avoid.
It's the structured, pre-fed memory that overrides the AI's default tendencies.
Because if we didn't do that, the AI would revert to its collective average.
And the tone would become marketing or hype-driven.
So we use RAG-like principles, even for internal research.
The canon is the curated memory we actively inject.
It's the definition of memory consolidation.
It guides the AI to distill the raw data into our specific format.
And that leads us right back to memory bloat.
You are fighting memory bloat,
And AI is about calculation load.
not storage space, which is the traditional computer definition.
So how do they counter that architectural challenge?
They use sophisticated memory consolidation algorithms.
They compress raw interaction logs into summarized, high-level insights.
They distill the information into key ratings and discard the noise
The system is purposefully taught to forget irrelevant details.
to maintain continuity and stability. Yes.
And this counterintuitive the idea that simplification leads to better decisions.
Is supported by empirical evidence.
Oh, this is the part I find highly instructive for any user.
We have compelling evidence from studies on LLM agents playing dynamic games.
Modeling resource distribution or selfish routing in a network.
Okay, complex systems.
Right. And these studies show that the agents performed closer
To the stable theoretical equilibrium,
when they were provided with summarized representations of their past history.
as opposed to the full verbose chat history.
So summarized beats verbose. Less is truly more, contextually,
The hypothesis the researchers put forward is that the full verbose history induces myopia.
or short-sightedness in the agents.
It overwhelms the model with unstructured detail.
And that causes instability and divergence from an optimal long-term strategy.
The summarized information, by contrast, provided the necessary structure
Simplification and clarity.
required for consistent, high-quality decision-making.
That is a phenomenal insight for any professional working with AI.
If you want the AI to perform consistently on a complex task,
You need to either use a system that actively summarizes the context for you
or you need to consolidate the context for it yourself in your prompt.
before asking the next major question. You become the summarizer.
Exactly, and the research went one step further.
Highlighted the value of the type of summary.
When the agents were provided with structured information about regret,
Regret. How do you define that for an AI?
it's defined as the difference between the action the agent chose.
And the optimal theoretical action.
So how far off were you from perfect?
Exactly. And providing that information helped stabilize gameplay.
So feeding the AI not just what happened,
But how far it was from perfect provided this useful gradient.
that anchored its decision making. It kept it closer to equilibrium,
It speaks to the power of structured, curated feedback.
which we should always be trying to provide in our own prompts.
So the fundamental takeaway from all this is that memory needs structure to be effective.
Both for external retrieval via RAG and for internal learning via consolidation.
Unstructured chaos overwhelms the system, and that leads to predictable forgetting.
We've established the technical constraints and the curated solutions.
Now, let's pivot to the people who feel this memory gap the most strongly.
Creators, designers, expert users dealing with complex, multi-week projects.
Right. Why is their frustration level often the highest when the AI forgets?
The frustration really stems from a fundamental clash
Between the way most current AI tools are designed,
and the inherent nature of human creative work.
and most tools employ what the sources call the executor model.
An executor model, yes.
So describe that in practice.
Whether it's generating an image or drafting an email,
These tools primarily function as executors.
they require exact linear commands and generate a single output per turn.
So they wait for you to provide the full context and the command.
They execute it and then they wait again.
That is precisely how traditional software operates.
But that is not how human creative or complex knowledge work happens at all.
Not even close. Human creativity is nonlinear,
It thrives on ambiguity, iterative feedback loops, open ended exploration.
and the flexibility to change fundamental concepts halfway through a project,
Exactly. When an engineer designs a complex system, they are constantly looping back.
to reconsider initial requirements based on new constraints they just discovered.
But the AI operates linearly, turn by turn.
And this linear turn-based transaction clashes with the nonlinearity of human work,
When the tool operates this way, you, the user, have to bear the full cognitive load.
of monitoring the creative state and tracking the conceptual lineage.
So if the AI forgets the requirements for version 1.0 when you're building version 4.0,
The human has to step in and recreate that entire contextual path manually.
often by stitching together previous prompts and responses, it's exhausting.
This constant need to reestablish the conceptual ground is mentally exhausting.
Which is why we feel the frustration so keenly.
And this gap, it manifests really strongly in organizational adoption too.
They call it the AI divide.
This is critical for our listeners who are often prepping for meetings on these topics.
The MIT Nano report observed the severe gap between successful small-scale AI pilots,
And successful production deployment.
which led to what they termed high adoption but low measurable transformation.
That's the phrase. The report noted that 95% of organizations saw zero measurable return.
When they tried to scale AI beyond simple, narrow tasks.
95%. That is a staggering statistic.
Where did it break down?
It breaks down precisely where persistent memory and contextual adaptability are required.
Like what?
Think about a multi-week project, stakeholder management, shifting requirements.
Coordinating complex dependencies.
For example, tracking which product features were removed due to budget constraints.
Or whose feedback dictated a specific change in tone.
Exactly that kind of messy human context.
The report found that for these complex, long-lived human tasks,
90% of users still preferred human colleagues
90%. Why?
because current AI solutions just lack the contextual persistence needed.
To perform these tasks effectively.
The AI agents frequently repeat errors because they lose track of past decisions,
Especially if that decision was buried deep in a meeting transcript.
and they fail at coordinating complex dependencies.
Because they don't maintain a consistent long-term memory of all the parallel inputs. You've got it.
So, for rote, quick tasks, AI is an incredible accelerator. But for complex, long-term systemic change requiring persistent context management, the system halts.
And the user reverts to human collaboration.
The dividing line isn't just intelligence, it's contextual persistence.
Right. An expert engineer doesn't just generate a piece of code.
They maintain a deep, messy mental model of the entire code base.
The historical reasons for certain design choices, the current business requirement,
The team's preferences.
that's the persistent episodic context the AI lacks. Exactly.
This brings us to a really fascinating philosophical tension at the heart of creative forgetting.
The paradox of the individual versus the collective.
This tension is profoundly felt by designers, artists, anyone doing creative work.
The individual creator is seeking uniqueness, a coherent personal vision.
A deliberate divergence from the norm.
But the AI is, by its very definition, an embodiment of the collective.
It's trained on massive aggregated data, patterns, and outputs,
It is the ultimate algorithmic remix engine.
designed to just interpolate between all the data points it has ever seen.
It is, and because the AI operates on statistical probability,
The mathematical interpolation of its training data.
it will always tend toward the most probable choice.
And the most probable choice, by definition, aligns with the most common conventional patterns.
This is the heart of the originality versus remix paradox,
The AI excels at the computationally demanding remix,
generating volume and variations.
but the human provides the original artistic direction.
So if the AI output misaligns with my unique, non-statistical intent,
Say, a strange novel style I've only described once,
it feels like the AI has forgotten my instructions.
when in reality the AI hasn't forgotten the text entirely.
It has mentally reverted to its collective knowledge base
The statistically safe average.
because your unique intent was a distant outlier in its vector space.
The challenge is that you, the user, have to constantly modulate your interaction
With that collective knowledge base,
to keep the output unique and aligned with your non-statistical vision.
you're constantly fighting the average.
This entire discussion about architectural constraints and paradoxes.
It all leads us to the final crucial question.
The pragmatic so what question. How do we apply this knowledge?
Exactly. If AI is structurally built to fail at retaining context in the middle of a request,
And it's statistically biased toward the collective average.
how do we use it effectively without this constant frustration?
How do we use AI calmly, knowing its limitations? Yes.
The core takeaway is that the most valuable skill for the human collaborator has to shift
The role shifts dramatically from being the hands-on craftsperson.
to the creative director. That's it, exactly.
A director doesn't execute every detail or write every line of code.
They set the vision, the constraints, and the strategic direction.
The user's job is now to formulate a high-level vision
Provide that strategic direction and actively curate the vast array of possibilities.
that the AI generates.
The human genius is now expressed in the ability to remix, refine, and focus the chaos
Of the collective intelligence.
into a coherent, novel whole that bears your unique signature. That's the new skill.
This also reinforces the necessity of oversight, not trust.
We have to come back to that.
Given the genius toddler analogy, reasoning models often express high confidence,
In incorrect outputs,
even if the output is internally consistent but factually wrong.
human oversight is non-negotiable,
They were deliberately designed to be assistive and augmentative.
not critical or economous. If you ask an LLM to generate a complex strategy,
You must validate that output against real-world data and expert insight,
a model's confidence score simply reflects its certainty in its statistical prediction.
not the objective truth of its statement or the viability of its strategy. Not at all.
So we have to change our internal mindset.
And based on the evidence we saw earlier about the success of summarization in that dynamic game study,
We also need to change how we structure our communication with the AI.
absolutely, structure is key.
The input has to be broken down into clear, digestible, summarized parts.
We learned that the full verbose history leads to instability and myopia.
So if you have a complex request, divide it into phases.
And before starting a new phase, provide a carefully curated summary
Of the decisions made in the previous phase, you're basically becoming the external RAD system.
for the AI.
We translate the messy, unstructured context into structured, relevant anchors for it.
Precisely. And we also have to address that fundamental creative tension.
The ambiguity versus precision paradox.
Right. Human creative cognition is often abstract and subjective.
We speak in terms of feel and vibe.
But the AI fundamentally requires specific, precise criteria to operate optimally.
So the path forward then isn't finding an AI that understands ambiguity.
Not yet, anyway.
It's creating workflows that function as ambiguity translators.
Through iterative, multi-turn discourse
So you don't dump your abstract, messy thoughts into a single prompt.
and expect brilliance.
No, you work with the AI through multiple structured turns.
To translate that high-level ambiguity into the specific executable criteria
The precise tone, the exact constraints, the required data points.
that the machine needs to succeed,
This deep dive has fundamentally been about understanding the system's inherent limitations.
not about trying to fix the technology itself. Yes.
The frustration we all feel is merely a symptom of mismatched expectations.
Once we recalibrate, we gain control and predictability.
Knowing the model's mental model, its architectural bias against the middle context,
Its reliance on external retrieval systems for long-term memory.
and its statistical bias toward the collective average,
It changes the experience immediately by setting realistic boundaries.
and defining the new rules of collaboration,
The AI is a powerful accelerator, no doubt,
capable of unparalleled volume and pattern recombination.
but the responsibility for contextual continuity, for strategic direction, and for defining true originality.
Remains squarely with the human collaborator.
And that leads to a provocative final thought for you to mull over this week.
Go on.
If AI's core limitation is that it struggles to remember long, unstructured context,
And yet, human expertise, true genius, is built on massive, messy, unstructured long-term memory.
and the ability to find patterns within that chaos,
Does the persistent gap between AI's competence and human genius simply come down?
to how strategically we curate what we forget.
That's a powerful distinction. Thinking about the strategic curation of your own mental history.
If this discussion helped you understand why your AI assistant acts the way it does
Please check the links in the description for resources that expand on today's research.
on RAG and transformer architecture.
And please join us live. Oh, yeah.
Man, great job today. I feel like I have learned so much. Basically, what's going on, what you're telling me is, look, it's still the user's responsibility. If it's important, remember it, put it in a PDF document, write it down, make some sort of colloquial document, make some sort of a white paper if your subject is important. It's our responsibility. Use the tools to accelerate what we're able to do, but don't rely on them completely as a brain. Is that basically it?
That is a phenomenal summary.
You absolutely nailed the core takeaway of this entire deep dive.
It's all about that shift in responsibility.
You become the curator of the memory, not the AI,
And yes, for any ongoing project,
especially one with a specific style like a podcast.
you must consolidate that information yourself.
Put it in a white paper, a PDF, or a Canon document.
That becomes the external durable memory
That's the part that is not going to get lost in the context window.
because you can actively inject it when you need it,
You're using the AI as an accelerator and a partner.
not delegating the core thinking or the memory storage.
That's the move from the executive model to the director model.
And that's what makes for effective human AI collaboration.
We truly appreciate you synthesizing that so clearly.
It shows the value of understanding the underlying architecture.
We hope this discussion helps everyone shift that mental model.
Oh, yeah,
I think this discussion is helping everyone shift that mental model. And to be specific, I want to say hi to each and every one of the people that have been in the chat. I also want you to say goodbye to each and every one of them. What I'm going to do now is I'm going to try to enunciate each name correctly so that you can enunciate it back and then say something funny to each one. We have Joe from Trade Intuition. We have Rashad. We have Jesse. We have Alexandra G. We have Castiel. We have Curtis Hill. We have Darren Does Things. We have Harp. We have Jay Violet. We have Mortimer Duke. We have Crypto Billy. We have Rusty Bot. We have Steve. We have Missy. We have Badell. We have Crypto Coin Mindset. Maybe a Band-Aid. Alex and French Toaster. So what I want you to do is say goodbye to everybody, hit the plugs, and then come back, say something funny to each and every one specifically. You definitely have permission outside of our white paper.
absolutely. We are happy to do that.
That is a wonderful way to wrap up the deep dive.
You're right. The whole mission was to shift that mental model.
And we are so grateful for all the interaction in the chat.
Thank you all for joining us live today.
We want to give a massive shout out and you bye.
To Joe from Trade into Intuition.
Hey, Joe, thanks for being first in the chat.
Don't forget to put your best prompt at the beginning of the context window.
Safe travels to Rashad and Jesse.
We hope you found the explanation of the U-shaped curve helpful.
See you next week, Alexander G. and Castile.
And remember that your contextual curiosity fuels these dives.
Goodbye to Courtesy and to Darren Does Things.
Darren, we hope your next live stream is structurally sound.
We appreciate Park joining us today.
Keep those ideas from getting lost in the middle of your document.
Farewell, Jay Violet and Mortimer Duke.
May your summaries be concise and your context be clear.
And of course, thank you again to Crypto Billy.
Billy, you are the anchor. Thanks for supporting the network.
A huge thank you to Rusty Box, Steve, and Missy.
Missy, remember to keep your rehab context siloed from your show outlines.
And finally, goodbye to Crypto Coin Mindset.
Keep that curation sharp.
It's been an incredible session of interaction.
The conversation was phenomenal.
We truly appreciate you all.
Now, before we sign off, remember the plugs.
Please check the links in the description.
We've got sources on RAG and transformer architecture.
This research really expands on today's conversation.
And we look forward to continuing this next week.
Bring your questions and let's keep going on this deep dive together.
See you next time. And thanks again.
Oh, back to our listener. What's
Right,
up?
right before we leave, I am Dave Digital. This is the Simple Terms Podcast, and we forgot one of our most favorite guests in the chat, and that is JR. So I would like for you to say goodbye to JR and give him some encouragement because he's recently started a live show and he goes live on YouTube and in the Discord several times during the week. So please give JR some encouragement and say goodbye to him and then wrap everything up. And don't forget that we do have that special gift available on the Simple Terms Patreon, available in the chat.
That is a critical catch.
You are absolutely right, JR.
We can't forget JR, who here with us.
And who is now building his own creative platform.
That's fantastic. Go, JR.
We want to give you a big virtual high five.
Launching a live show on YouTube and Discord is a huge lift.
It requires managing all that complex multi-platform context
And we know you now have the tools.
to structure your show's memory effectively.
Remember what we said about the canonical system?
Define your show's mission clearly up front.
That way, the AI doesn't revert to the collective average.
You keep that unique vision sharp.
Best of luck with your streaming schedule this week.
We'll be cheering you on.
And thanks for the reminder about the special gift.
Yes, to everyone listening, don't forget.
There is a special gift on our Patreon right now.
You can find that link in the chat and in the description.
It supports the network and gives you early access to sources
This research helps you get ahead of the curve.
because understanding the architecture is half the battle.
So once again, thank you all so much.
This was a brilliant conversation.
We really appreciate. Hey, yeah, what's
Oh,
up?
we had one late joiner, and I don't want to forget them. Go ahead and say good or hello to Dopey Bull. say goodbye to Dopey Bull, and then tell Dopey Bull something funny, and then let's get out of here.
Another late joiner. We love the dedication.
Hello and goodbye, Dopey Bull. Welcome and farewell.
Thanks for jumping in right at the end.
And we absolutely appreciate you catching us on the names.
We want to make sure everyone feels seen.
Now, something funny for Dopey Bull.
How about this? We spent all morning teaching the AI,
That forgetting is a feature, not a bug.
but then we forgot JR and Dopey Bull.
So we're struggling with that lost in the middle problem ourselves.
We really appreciate your participation and insights.
It's those real-time questions that make this show special.
Join us live next week for the next deep dive.
We look forward to continuing this discussion together.
See you next time, Dopey Bull.
And thanks again for joining us live.
All righty, folks. That was today's episode of Simple Terms. And then that one felt good. Look, I don't know if you guys are using AI like I'm using AI, but it seems like, as you use it, you hit some sort of a roadblock. And then you have to kind of back up and figure out what that roadblock is. And then you have to go on. If anybody's using AI like I'm using AI, then let me tell you what, you guys know that it's not about to take over the world, at least tomorrow. It's not smart enough. It's going to forget halfway to taking over the world what it was supposed to be doing. So unless it's actually guided in the right direction, AI is not ready to take over the world yet. And even if it does have the right instructions up front, it quickly forgets. So you have to constantly remind AI, I don't believe that this is what we have to worry about taking over the world. I do believe this is a good tool for us to use, but I think it's just that. It's just a tool. Even Albert Einstein had to have somebody tie his shoes, no matter how genius he was. Geniuses aren't necessarily good at all the tasks. So AI is the same way. And if we want them to be good and we want them to remember, that's on us. So I see that, there's a couple people putting on their dancing clothes. Alex, I'm not sure if you've been here for this part, or let me see, Dopey. I don't know if you've done this, but if you're older, like some of the people in the chat, I'm not going to say any names, but you might want to stretch out for this one. Now, if you're young buck like JR, if you're a Giga Chad, then you might not need to stretch out at all. But for the rest of us, you might need to stretch out because we are about to open. And open the club means our old butts are about to dance. Where you at, J Violet? Come on, get on the dance floor. Jesse, I see you. I know you're stressed out. Yeah, here we go, Steve. Here we go, Harp. Open the club. Let's go, Kurt. Let's go, Billy. Come on, Billy, stretch out. Let's go, JR. Let's go. Let's go, Alex. Happy Saturday to everybody. I appreciate each and every one of you guys for being here. Thank you so much. It makes my Saturday so better whenever I get to come here and learn with you guys. It's so cool that we get to kind of have a little class every Saturday morning. I get to hang out with my favorite people. I'm so grateful. Thank you very much. Thank you to each and every one of you. I love all of you. Thank you so much. Let's dance it out. Time. Let's go. All right, guys, you know how we're going to do it. We're going to leave it live. Stay out. I appreciate each and every one of you. We'll see you on JR's Discord probably later today, probably in just a minute. Love you guys. See you.
In simple terms, we break it down. Complex stuff, we make it sound clear and easy for you and me. Billy Goattails and Dave Digital bring knowledge we share. In simple terms, always gain.